Hello everybody, get ready to do lesson 5.2 of 6th grade math, part 1 today, and then we have a 26-point skill sheet for classwork, and then 4 points here of notebook taking today. 5.2, adding and subtracting decimals, part 1, operations with decimals. Here's our standard here. Teachers, today's bell work is multiplication here for your students. Give them about 5 minutes to complete this. Okay, welcome back. 4.9 is our solution here for number 5. 25.34 times 1,000, that's 25,340 for number 6. And then 87 times 100 here is 8,700. Into our lesson today, essential question, how do you add and subtract decimals? Our explore activity will include that. So modeling decimal addition, you probably use decimal grids to model decimals. For example, the decimal 0.25 or 25 over 100 can be modeled by shading 25 squares in a 10 by 10 grid. You can also use decimal grids to add decimals. So okay, well, let's see what that's about. 0.17 milliliter water and 0.49 milliliter of hydrogen. A chemist combines that much in a beaker. How much total liquid is in the beaker? So how much total liquid we got of water and hydrogen? So how many grid squares would you shade to represent 0.17 milliliter of water, and why is a question here. So here will be a grid, 17, because 0.17 means 17 over 100. So in a decimal grid, you would shade in 17, like for example here, just be the way you would do it here, 10 plus 7. So that's the idea behind decimal grids. How many grid squares should you shade to represent 0.49 milliliter of hydrogen peroxide? What would that be? 49, because 0.49 means 49 over 100, and so you would add 49 to your 17 up here, right? So that's the idea behind decimal grids, is to give a visual representation there of an addition. Use the grid bottom right to model its addition. Use 0.17 of water and another color for 0.49. So students, you should have this on your classwork sheet. You should have colored pencils actually in your classroom for this, and you should come up with something like this. Is what you should. This represents your addition here of water and hydrogen. How much total liquid is in the beaker? So how much total liquid is here in this beaker? And it'd be 66 here, so we'd have 66 of these things colored in. That's the idea behind it. Okay, reflect here. Show how to shade each grid to represent the sum, then find the sum. So 0.24 plus 0.71 equals what? So there's 0.24, then 0.71, then what does that equal? 0.95, right? 0.24 and 71. So we have 5 empty spaces here. That would be a complete 100. Reflect now. Show how to shade each grid to represent the sum, then find the sum. So we get the color here, class. 0.08 plus 0.65 equals what? So this would be 8 here, and then 65 here. How much would that equal? 0.73, right? We have 70, and then 3 more, it'd be 73, 1, 2, 3, 4, 5, 6, 7. Then plus 3 would be 73. See how that works? Adding decimals is similar to adding whole numbers. First align the numbers by place value starting at the right and regroup when necessary. Bring down the decimal point in. Okay. Sounds like fun. So she rode her bicycle 3.12 miles on Monday and 4.7 miles on Tuesday. How many miles did she ride in all? So how do we figure that out? Align the decimal point. So here's the decimal point here. We got decimal point there and there, okay. So add zeros as placeholders when necessary. So here's 0 here, and add from right to left. So we got 3 here, we got 4 here. This should be an addition line here to separate our two sums here from our final answer. So 3 and 4 is 7, right? 3 plus 4 is 7. Susan rode 7.82 miles in all. Well, wait a minute. How do we know that? Well, we have 1 up here. Then we have 7. So we have 1 and 7 in the tens place there, I think. Tens, hundreds, yeah. And then 1 and 7 is 8. 7.8, we got that much. And then what do we have over here? We got 2 here, but we won't have nothing here. So we just add 2 and 0, and that equals 2. So this is how we get our 7.82, correct? We keep everything in columns. That's really important when you add decimals. You got to keep it organized. Use estimation, check the answer is reasonable, round each decimal to the nearest whole. So here's our situation here. Since blank, we got a bunch of blanks here. 3.12 is 3. It's close to 3 miles, yeah? Close to 3. And then 4.70 is close to what? 5 miles, right? So 7.82 is close to around 8, right? And 7.82 is pretty close to 8. So it does sound reasonable. And since 8 is close to 7.82, the answer sounds reasonable, correct? Yeah, that's correct. Okay, so that is lesson 5.2, part 1. Part 2, part 3 is available at the email. Thank you very much.